Welcome back to Simply AI, a place where I explain all the complex and related AI concept in a simplified and easy to understand manner. So this is the third video in this series, and in this session, we are going to discuss about the linear regression implementation from the start to end. So in our first video, I think we have discussed the linear regression as a concept, and then we discussed the gradient descent, and then we implemented linear regression using one feature, and then we implemented it for two features and the normal equation. So that was our flow. I think this was the program for the linear regression one for one feature, where we take our hypothesis as a one simple line, which is y equals to mx plus c, and then we try to train that line using gradient descent. Then again we take the the two features where our hypothesis is the plane instead of the line, right? And here the thing is, if you will see, the input we have taken is the one array, so one feature represents the one array, right? In linear regression, the taking input was the way better than other two approach, where we have taken the the input data as a matrix, where each row represents the one training set and each column represents the one feature. So this is the final thing which we have, right? We have training set, we have our hypothesis, we have the our cost function, which is the squared loss, and we are going to discuss this y squared loss in probably in next session. And then we are using gradient descent for optimizing our parameter or optimizing our theta. Let's implement the same program where we are taking input in a matrix, and then we are using the gradient descent algorithm in order to optimize our parameter instead of the using normal equation. uh, so again, the normal equation is only for linear regression, so that is the one reason that we usually don't prefer normal equation, but you should know that what is the normal equation and why don't we use that. So that's why in last session we discussed about the normal equation. So let's create the new file. Here I've created one for the demo. You can create a new file here, which is the so this is a new notebook. Uh, I'm going to write the code from the scratch. Few of things, we know that we have already implemented, but still, I'm just going to write everything from the scratch. We are going to use the Boston housing price data set for this. So let's do that. And the one more thing we needed is the random. Uh, okay, so our data is the pandas dot read CSV. We're using the CSV file, and our location is the data boston.csv. We're just going to do the data.info just to check what is the data. So these are our all the columns which we have. The last one is the price, which is MPV, and the others are the features like the age of the house, the area of the house, and so on. So the one more thing we are going to do is I'll say the NumPy data, where I'm going to convert this thing into the NumPy array data. So now if you will print the type of the NP data, so it's NumPy dot n-dimensional array, right? So whatever the operations we know, like slicing and all, and that's easy to do in NumPy. So we are going to do everything in NumPy. Okay. So let's move on. Our next step is normalizing the feature. So we can just say so feature normalize. So what is a feature normalize? As we saw in our previous example, if we take housing.csv instead of the boston.csv, because housing.csv has lot of big values. So when you do the matrix multiplication and all, it will throw the error because it will just go, the uh, so it will throw the error because it will just go out of memory, or it will throw the some error, right? Because there are so many values. So if you are doing the dot product and then you're summing those things, and since there are some 10,000 records, and if you're doing the sum of all those records, your value is going to uh, go out of memory exception or something like that. So that's why the normalization comes in a picture, where you normalize all of your values so that you can train your model without having any error or anything. So I found this very useful link, and I think it's very explanatory, where it's a Google developer docs where you can see all the techniques which we follow to to normalize the data. So the one technique which we are going to follow is the Z score, right? So when the feature distribution does not contain extreme outliers, then we are going to follow the Z score, where you know we are going to compute the mu, and we are going to compute the value of sigma, and then we will just implement this formula, and this is going to be our final input. For now, I'm just going to implement or going to create the one uh, method which will be feature normalize, and it's going to take the x as an input. Now, how do we do this thing? So there are two uh, things. One is the mu, and another one is the sigma. And your final result is going to have the same thing. So what is mu and sigma? So here, the mu is the mean, and the sigma is the standard deviation. So what does the standard deviation mean? I'm not going to go there. For now, I'm just going to write the program, and later on in the next session, we are going to learn about these terms in more detail. So what it will do, I think we'll just go here and see. Uh, so this is the example. So if your matrix is 1, 2, 3, 4, and you're just telling np dot mean, it will calculate the mean, like summing all the values by the total number of values, which is 4 here. So it will be 2.5. And if you specify the axis, in our case it's 0, so it will just take the column values. So first column 1 and 3, 1 plus 3 is 4, 4 by 2 is 2, and then 4 and 2 is 6, 6 by 2 is 3. So this is our the final result. And if you will take the axis 1, it's going to be a row wise operation. So this is our mu, which is the mean of all the column values, and then sigma is the standard deviation. So NumPy has the inbuilt function for standard deviation, where this is our input and x is 0, because here DDOF is going to be okay. So I think you can again see the standard deviation means here the square root of the means of x. That is what the formula of the standard deviation, and this is what we are going to calculate. X is 0 means we are going to calculate for the uh, column. So now our formula was, if you will see, it was x minus mu by sigma. So that is our x norm. Why we are returning the mu and sigma? Because you're normalizing the value. So once you will give your input, it will return you the normalized input values. So in order to get your actual input values, you need mu and sigma, right? You're going to do the x norm into sigma plus mu, then you will get your x. So when we are going to write our predict function, we're going to use value of mu and sigma. So that is why the returning mu and sigma is important here. Okay, so this is the function which will just normalize. Now just let's prepare the data. Now our task is to get input mu sigma, and we are just going to normalize this. We're going to pass input. So this is going to return the input. One more thing I just want to say is, so what it is going to do, it's going to create it's going to create the the vector of 1. So if you will see in our here, right, the x0 was 1, so we have taken theta 0 into 1. So we want the first column to be 1. So for that, what we are going to do, we are just creating np dot ones, which will create the uh, column vector, and the size of that vector will be output save char 0, which is the total number of the rows we have, and it will just append to input. So here, if you will see, the first the column is going to be 1, and then other column is going to be the other features which we have. So this is what our input and output looks like. Now in our next step is we are going to learn about theta. We are going to just say this is our initial theta. Let's just plot this for with respect to only one feature. Okay, so this is a initial uh, line. Suppose if you are taking the random theta, our line will look something like this. So it's not trained, but it's initial. We are taking the 0 0. We'll take both. It will not like it's not a very big model where it's going to take some time. Now let's write the our loss function. And loss function is taking the input, output, and theta. And so this is our initial loss. Now we are going to write the gradient descent. So I'm just going to take the epoch 1000. Epoch means the number of iteration, the alpha 001. Okay, and gradient descent, the input, output, and theta. Okay, so if you will see, it's running, and for first epoch, our the loss was 261, and for the last one it was some 10.9. Now let's plot the same thing what we have done earlier, right? Now the last one, the predict function, here you just cannot use the or theta directly to predict price. So let's write the predict. So our actual price was 34, but it predicted 30, 30, right? It's not accurate, but it's near to that. So we'll see. Okay, so I think this is the complete overview of the linear regression from the scratch. Here, I have fast forwarded few things. So if you guys haven't watched the previous videos, which has the proper explanation of each and everything, then please go and do watch those videos. And yeah, that is it for now. In next season, we are going to continue with linear regression only, and we're going to use the one Uber data set from Kaggle, and using that data set, we are going to build a model for predicting your Uber fare. So that is our next video is going to be about. And then there will be a very this small, and then there will be a very short discussion about another approach. And what is another approach. We'll discuss this in our next video. For now, I think that is it. If you guys have any question or query, you guys can comment it down. I will try to reply over there. Please don't forget to share this video, like and subscribe this channel.